So you want to learn how to turn this into this. Well, you've come to the right place. There are a few things you need to know before you get started. First of all, you should know how to solve a 3x3. This will introduce you to a lot of concepts and terminology that'll make it a lot easier for you to understand this tutorial. You'll also need how to hold and turn a square-1. You hold this side up and this side in front with the small side on the left, and you turn only the right, the top, and the bottom. You should also understand notation. Square-1 algorithms and scrambles have a series of numbers and slashes. It can be intimidating because it's not very similar to the notation of most other puzzles, but it's actually pretty simple. The first number in each pair is for the top layer, and the second is for the bottom. A slash means a slice move, like this. The edge is 1, and every corner is 2. Positive is clockwise, and negative is counterclockwise. So this out, for example. So it's 1, 0, so clockwise by one edge on the top layer, and then nothing on the bottom layer, slash. Then 0, -3, that's nothing on the top layer, and then an edge and a corner counterclockwise on the bottom layer, slash, and then -4, 2. So the top layer goes counterclockwise by 1, 2, 3, 4, and then the bottom layer goes clockwise by one corner, 1, 2, slash. Next, let's do an overview of how a square-1 is solved. First, you bring it back into a cube shape. Then you separate corners into the correct layer, then edges. And that's called corner orientation and edge orientation, even though you're not actually flipping pieces in place, you're just bringing them into the correct layer. Then you permute corners. Then you permute edges, solving parity if needed. So first, cube shape. The easiest way to do this is to first bring all 8 edges all together on one layer, like this. To do this, generally you want to preserve pairs and even numbers of edges. So like here, we can match up these two with these two to make 4. Now a lot of times you'll run into a case something like this, where you have 6 all together on the top, but then the last 2 are in an L shape like this. And when they're like this, they're kind of hard to pair together. So what you want to do here is bring up the L to match with 4 of the 6. And then this shape is useful because you can break off 4 either this way, leaving an L, or this way, leaving a line. Generally you want to leave off the line. So here you can break off the 4, leaving the line, pair them up with the other 2, so then you got 6, and a line. You can bring up the 6 to match with the line like that, and then you have all 8 together. Once you're here, getting back into cube shape is pretty easy. You just have to remember to split each layer symmetrically down the middle with each move, and most of the time both layers will be in the same position. So here, we just split all the edges down the middle to make 4 and 4, then we split them all down the middle again to make groups of 2. Then here, we don't set them to the same position, because that would just give us the same case over and over again. But we set them against each other, still splitting each layer symmetrically down the middle. And then last one, back to the same again, symmetrically down the middle, and we're back in cube shape. Sometimes the middle layer might be off like this. That's okay, you don't have to worry about that until the end of the solve. As long as both layers are square, you're still technically in cube shape. So once you're in cube shape, you probably want to stay there. So to do that, before you make any turns, you should adjust one of the layers by one edge. So that way, it'll stay in cube shape. So next, corner orientation. This is probably the easiest step in solving a square-1. It should be pretty intuitive to just match corners up until you have all the yellow ones on one layer, all the white ones on the other layer. Here on, the rest of the solve is basically just algorithmic. Each of the next 3 steps will have a base case that you'll usually need to apply multiple times to solve the step. So now, edge orientation. The base case is when there's only one bad edge on each layer. So here you put the one on the top, on the right, and the one on the bottom in the back. So here's the alg. 1, 0, 3, 0, 3, 0, -1, -1, -2, 1, -3, 0. So here, you adjust the top layer, then move it over by 3, and then 3 again. And then here you just adjust each side by 1, and then you move each piece over this way by 1 piece, and then you move it back over 3. Next is corner permutation. The base case is just one adjacent swap like this. You put the headlights in the back, and then here's the alg. 3, -3, -3, 0, 0, 3, 0, -3, 0, 3. So basically, move both of them over that way, then move the side that needs the swap back, and then it's going to stay there, and the bottom goes back and forth. When you need to do a swap on the bottom, you have a few options. One is you can switch layers by doing /6/6/, and now the white is on top. But I think it's better to use the up-down mirror. You just switch the top and the bottom in the alg. So you move them both over, and then you move the bottom over, whichever side needs the swap. And then the other side, this time the top, goes back and forth. Next is edge permutation. It's a little different because the base case is parity, just a single swap like this. And you really don't want to do the parity alg more than once because it's really long and complicated, so this bonus case is pretty important to learn. So you have an adjacent swap on each layer, like this, and on the top you put them in the front and right, and in the bottom you put them in the front and left. The alg is 1, 0, 0, 3, -1, -1, 1, -2. So you adjust the top, move the bottom over by 3, adjust them both by 1, move them both back over by 1 piece. Once you know you have parity, you can do this algorithm. It isn't the fastest parity algorithm, but it's probably the easiest to remember. So you basically undo what you did to solve cube shape. So, right here to here. And then here, instead of putting all the edges on the top, you can just put them all on the bottom like this, in this shape. And then you're going to adjust the top layer by 1 corner. The reason this solves parity is because it does a 6 cycle of edges, and so that's an odd number of swaps, which is odd parity. And then you just resolve cube shape. Now it looks like you're starting over back at corner orientation, but it's actually very easy to get back to edge permutation. Just do 0, -1, -2, -2. And now parity is solved. And then before it's completely solved, there might be a couple more things that you have to fix. One, if the middle layer is off like this, you just do /60/60/. Another situation is if it's like this, where the front and back are matching, but the left and right are opposite like this, or vice versa, like that. You just have the layers switched. So you just switch the layers just like I told you during the corner permutation step. And then it's solved. Congratulations. Next, I'd recommend looking at some of my beginner example solves just to make sure that you fully understand. If you've learned all of these algorithms and can consistently solve it on your own, and you want to get faster, take a look at my intermediate Square-1 tips video.